In this video, we want to take a look at how to solve an absolute value inequality involving a less than and greater than symbol. So first we'll solve this question, and here are the steps. So as we can see, the first thing we want to do is isolate this absolute value x plus 8 term. So we could start by subtracting 10 on both sides. So in the next line here, we're going to have 9 times the absolute value of x plus 8 is less than 45. So next what we could do to complete the first part of this question is divide both sides by 9. And now we have the absolute value of x plus 8 is less than 5. Now for this part, you could just memorize the steps here and use that to solve the question. But if you want to understand the concept, really think about what absolute value means. The meaning of this expression in words is that the distance of x plus 8 from the origin is less than 5 units away, and the origin is 0. So that tells us that x plus 8, if it's within 5 units of 0, that means that x plus 8 is between 5 and negative 5. So I could put a less than 5 here, and I could put another less than symbol and write negative 5 here. So once again, the distance of x plus 8 is within 5 units of 0, which means x plus 8 is between negative 5 and 5. So we could write this compound inequality here. So then to solve, all we have to do is subtract 8 on all 3 sides of this compound inequality. And we'll have our solution that negative 13 is less than x, which is less than negative 3 when we do 5 minus 8. Now, in words, this means that x has to be between negative 13 and negative 3, but not including those numbers. And if we have to graph the solution, what we could do is make a number line. Sorry, let me try again. That was sloppy. So we make a number line, and we mark it at negative 13 and negative 3. And it's all the numbers between negative 13 and negative 3, but not including. So we put open circles here because this was strictly less than, and we just shade everything in between those two numbers. So that's the solution to our first question. Here's the solution, and there's the graph of the solution below. So for the next question, now we're dealing with a situation where we have a greater than. So here are the steps in this case. So same start to as we had to the last problem. We're going to start by isolating this term. So we're going to do plus 3 on both sides. But now for the next stage here, once again, you could just memorize the steps, but if you want to understand what's going on, the way you should be thinking about this so that you'll recall the steps is you want to think of numbers that satisfy this absolute value expression to make it bigger than 8. So what I mean by that is, let's say I were to take the absolute value of 9. That's definitely going to give me something bigger than 8 because the absolute value of 9 is 9. And if I were to write a 10 in here, the absolute value of 10 is bigger than 8. But the second case that people often forget is the negative case, that I could have the absolute value of negative 9, which would give me positive 9, which is also greater than 8. And this could carry on this way. The absolute value of negative 10 also gives me something bigger than 8. So when we set up the next stage, or when we set up the next part of this question, we want to keep this concept in mind, that the inside n minus 2 is going to basically just be a number that's either bigger than positive 8 or something less than negative 8, because see how we had negative 9 and negative 10. So we said just now that the inside n minus 2 is either going to be bigger than 8, or the inside n minus 2 is going to be less than negative 8. So when we solve these two inequalities, we're going to have our solution. So we're just going to work out this basic algebra, and we'll have n is greater than 10, or, which we could replace with a union symbol, we'll have n is less than negative 6. So here's our solution to the second question here, and the last thing we'll want to do is just to sketch or graph this solution out. So I'm going to make a number line here, and we're going to mark it off at negative 6, whoops, not negative 16, negative 6, and positive 10. And we just want to color in or shade the solution. So we have n is greater than 10, is going to give us all the numbers here that are to the right of positive 10, and n is less than negative 6 gives us all the numbers shaded to the left of negative 6. All right, well, this is going to conclude this video. If you found it helpful, please click like and subscribe below, and thanks for watching.